Okay, so in this section, this is section 6 of chapter 4. We're going to be talking about something called a force couple, a force couple, all right, or sometimes called a couple moment. All right, you can see there. And basically, when we have something we would call a couple moment or a force couple, it's two equal and opposite forces acting together. And together they produce a certain moment. All right. So think about the two 400 Newton forces right there. Let's suppose that we called this guy F1. And so then the other one we're just going to call minus F1. All right. And these are both force vectors. Okay, but they're opposites. All right. Um, And then suppose we just decide to be kind of arbitrary and think about a moment generated by um, F1 that's going down. Okay. So what we could do is we could say, let's create a moment arm. We're going to come from some arbitrary point all the way up here, just like this. And let's call that R1. And we know that the moment generated by R1, it is going to be R1 crossed with F1. Okay, so that's pretty easy. Now, let's think about if we made from that same point, we made another vector here out to the other guy. Okay, and so that becomes, I'm going to call it M2, and we'll call this R2, is R2 crossed with minus F1. All right. Is that making sense? But now let's suppose that we say that there's a vector D that goes from one force to the other, just like that. So there's my D vector right there. Boom. Okay. In this case, it'll be, let's call it D1, I guess, mine as well. Okay. And you can see that R1 plus D1 is R2. So let's do a little bit of algebra. Although it looks like I need to make these guys a little bit. Oops, no, and that was a mistake. Okay. So anyway, let's get in here and we can write M2 is R2, but R2 is R1 plus D1, and all that is crossed with minus F1. Okay. Now, we can do this just like distributing terms. All right. We got something plus something, both of them times something. And so M2 then is going to be R1 crossed with minus F1 plus D1 crossed with minus F1. Okay. Now, let's suppose we add M1 plus M2. So if we do that, M1 plus M2, okay, what we're going to end up with is R1 crossed with F1 plus R1 crossed with minus F1 plus D1 crossed with minus F1. Ooh, got really sloppy there. I apologize. That's a minus sign there. Okay. Um, Now, look, this term and this term cancel each other out. All right. And all that we're left with is D1 and F1. D1 and F1. Okay. So we've got, I'm going to say minus D1 crossed with F1. Now, before we simplify things any further, what you need to realize is that I never told you what this position was right here. We never actually said what R1 was, but the result I got is completely independent. It doesn't matter. We could put it right there where I've got it. I could put it over here. I could put it up here. I could put it right here. I could put it right in between the two. It doesn't matter. The only thing that matters if I add the moment up for these two equal and opposite forces is the magnitude of them and the distance between them, just like that. Okay. Um, so if we think just in terms of the magnitude of what's happening, then M1 plus M2 is going to be D1 F1 sine theta. Now, in our particular case, the way it's drawn, sine theta is 1 because theta is 90 degrees. Okay. So whenever we have two equal and opposite forces in a situation, we can say that the moment that they generate depends on the perpendicular distance between them times the magnitude of them. Okay, just one of the magnitude of one of them. All right, so that works out pretty good. And so what we've got here in our particular case, then we could say that the actual, what I'm going to call M1, the moment generated by the 400 Newton pair of forces, is really the distance between them, which is 2, times the magnitude, which is 400, just like that. Okay. Now, we probably need to sort of think about having a plus or minus on here. So if we look at our 400s, okay, one's up, one is down. And so you can see that's going to try and go around this way. All right. So it's like going to crank around. And so that's a positive moment. So that's positive 800 Newton meters right there. Okay. Now that might, well, okay. What I want to ask is, does this ever happen in real life? Do you ever get equal and opposite forces acting on something? And at first you might kind of think, well, I don't know. However, have you ever turned a knob? If you've turned a knob, you've done this. Okay. Let's suppose this is my knob. All right. And it's sticking here. And I come along and I want to turn the knob. Boop, boop. Okay. Well, in order for me to turn the knob, I apply a force this way towards me and a force that way away from me. All right. And we just do this, we make them equal and opposite. If I add these two guys up, because they're equal and opposite, they're going to add to 0. So my rotation like this doesn't put any stress on the actual mechanism other than to twist it. So it doesn't try to push it towards me, it doesn't try to push it away from me or up or down. All it is going to do is try to rotate the thing. Okay. So we actually use these force couples quite a bit. Okay. So now let's get to this actual problem. It says determine the resultant couple moment acting on the beam. Okay, there's that word resultant. We haven't seen that in a little while, but it basically just means if you add stuff up, what's the result? All right. And so from our 400 couple moment, we get a moment of 800, but we've got two more. All right. So there's the 300s there. So let me rename those. And let's say this guy right here. Oops. This 300 on the right, I'm going to call that minus F2. So then on the other side, I've got plus F2. All right. And so if I want the moment from those forces, I would say M2 is plus or minus the distance between them times their magnitude. Okay, now in this case, if you look at that, they're going to be acting together to create this kind of emotion. All right, so that's going to be clockwise, so that's negative. Okay, and so we would say M2 is minus 5 times 300. So we get minus 1500 that way. Okay, then we've got one more force pair. And let me call this guy F3. So that makes the other one negative F3. Okay, and so M3 plus or minus D3, the shortest distance between them, F3. And those guys there, we got one here, we got one here. So it's going to be doing the same sort of thing in that it's going to be a clockwise moment. So that's going to be minus. And the distance there between the two of them is 0.2. And the amount of it is 200. So we're looking at minus 40. Okay. So I've got M1 is 800, M2 is minus 1500, M3 is minus 40. So the whole kit and caboodle acting together, the total, we're going to have M1 plus M2 plus M3. Okay, so we've got 800 minus 1500 minus 40, and that's negative 740. Okay, and that's, of course, is Newton meters when we do that. Okay, so the idea of having a couple moment is very useful, actually. And if you've got a whole bunch of them acting on a system, you could just add them up. That's just fine. And we're going to see in another example here pretty soon that that even works in three-dimensional space. Okay. All right. So there's our idea. Force couple is opposite forces, and the moment depends on the distance between them, and that's all. The two forces and the distance between them.